2.5 million light-years away, our cosmic neighbor holds secrets that fundamentally changed our understanding of reality. Today, NASA's most powerful X-ray telescope has given us an unprecedented look into the Andromeda Galaxy. This isn't just another pretty space picture. What Chandra revealed about Andromeda rewrote the laws of physics and uncovered the invisible universe that surrounds us all. This breathtaking image represents one of the most ambitious astronomical collaborations ever attempted. 7 different space telescopes and ground-based instruments work together to capture Andromeda across the entire electromagnetic spectrum. Each instrument sees something different. NASA's Chandra captures deadly X-rays from the galaxy's most violent regions. The SpaceVrse telescope reveals warm dust clouds. Radio telescopes detect magnetic fields. Together, they create a complete portrait of our galactic neighbor. What we're looking at here is 2.5 million light-years of distance, meaning we're seeing Andromeda as it was when our earliest human ancestors were just learning to use tools. At over 200,000 light-years across, Andromeda is twice the size of our Milky Way and contains over 1 trillion stars. But size isn't what makes this galaxy truly remarkable. At Andromeda's heart lurks M31 star, a supermassive black hole that dwarfs our Milky Way's central monster. Chandra's X-ray vision reveals the high-energy radiation streaming from this cosmic beast. While our galaxy's central black hole, Sagittarius A star, weighs about 4 million times our Sun, M31 star is a true giant, containing the mass of 140 million suns crushed into a single point. The X-rays Chandra detects tell a story of destruction and creation. As matter spirals into M31 star, it heats to millions of degrees, creating a cosmic lighthouse visible across the universe. Rubin was studying how fast Andromeda rotates. According to physics, stars on the outer edges should move more slowly than those near the center, just like planets in our solar system. But that's not what she found. Instead, stars throughout Andromeda were moving at roughly the same speed. This should be impossible. There wasn't enough visible matter to hold the galaxy together at these speeds. Andromeda should have torn itself apart billions of years ago. Rubin's solution was revolutionary. Andromeda must be embedded in a massive halo of invisible matter, something that doesn't interact with light but has gravitational pull. She had discovered dark matter. This discovery shattered our understanding of reality. Everything we can see, every star, planet, and galaxy, represents only 15% of the universe. The remaining 85% is invisible, composed of dark matter and energy. Dark matter forms the invisible scaffolding upon which all cosmic structures are built. Without it, galaxies like Andromeda and our Milky Way couldn't exist. Today, physicists worldwide are racing to identify the mysterious particles that make up dark matter, potentially discovering new physics beyond our current understanding. From revealing supermassive black holes to uncovering the invisible universe, Andromeda continues to be our cosmic teacher, showing us that reality is far stranger and more wonderful than we ever imagined.